All right, I think we're on. Let's see if that echo goes away. Echo, you clean? Welcome to Bangkok. So I got the slides here. So I don't think you'll need to share them as we roll, but I believe we've got, we need to take a, well, let's say no well first. Welcome to Bier. You're in the right room. Look at this. So what's the scoop here? If you write your questions in, it all gets logged, but we still need a note taker. Isn't that correct, Tony? Tony, anyone hear me?
Okay, volunteers for the minutes.
Somebody.
Otherwise, we shall pull a random person and take the next one after her. No one? Come on. All right, fine. I'll do the minutes.
Who's that? Do we have minutes?
Minutes if nobody volunteers, that's fine.
Your audio dropped out a bit there, Tony.
Yeah, can you paste the link into the chat? Then I pick it up and I will be taking the minutes, okay? Not above that. And we have an exceedingly lazy crowd tonight. That's okay. Thanks.
Looks like there's a space there.
I shall handle that.
So Tony, can you pay attention to the queue as well? Or you want me to do that? You can bounce back before someone's got to mount that, and then there's questions come up. So I guess we can look back and forth.
Say again?
You call. I'll run this.
I don't know what you asked.
No, just managing the queue. See whose hands are up.
Oh, okay, yeah, I can manage.
The questions are coming up, you know, people at the mic, so we can keep this thing flowing.
Okay.
Okay, so here's the current agenda. We shuffled some things around for the sake of discussion from recommendation of the AD. We also had some time crunches for at least one agenda item here, so we moved it accordingly. Let's see, we have a panel. You can also click on note-taking tool, top right. Look at that. See that, Tony? In the notes. All right, any issues with the agenda? We straight? Great. Right into status. So we have a bunch of docs in our queue. Most of them have gone through last call. Some have Shepherd, some are looking for Shepherd, some are waiting for Shepherd write-ups. Some need other reviews from other groups. At least one I've sent over and gotten no response. I probably should have gone to the chairs and solicited some help there, but that's our next step. So let's go through them individually and we'll find out who's on the scope here. So the IPA, the bar IPA, we got consensus. Shepherd's done. We're waiting for LSR to review. This is the one I bounced LSR. I've heard nothing from them. So we'll have to shake them up with the chairs. And of course, I'll CC the AD. You get the AD's big stick in the game as well. BGPLS, again, in last call, review's done. Comments have been addressed. Now, Alvaro, do you think this needs to be an IDR review? Again, I mean, after the last comments. Alvaro, see here, he's there.
Me?
There we go.
Yep. Okay. I don't know. It says here that you already had idea review or not. It
Yeah,
says review again.
it went through before. We had some comments were addressed, and it looks like we do need to go back.
No, I would say that if they were reviewed it, no, giving them a heads up would be fine. Just
All right.
instead of, in other words, not necessarily wait for a review, just say, we already addressed everything. Here's the last one or whatever.
Excellent.
And
Thanks.
we should be able to keep going.
We got PIM signaling. Shepard's done. Comments have been addressed. Let's see, Shepard needs to upload the review in Tracker, and then we'll bounce it to, I guess, Stig and Mike over at PIM to get their input on it as well. Has this been presented in PIM, Stig? Let's see. I don't think it has. But at least, now we're going to review. We'll take it to the chairs there. Here we go, Stig.
Yeah, hi. No, I don't think it's been presented in PIM. So we can always take it to the PIM mailing list, but it might have been good to have it presented.
Well, let's see. I mean, it ultimately requires reading the draft, and we need review from the working group on that. So we'll take it to the list with your permission.
Yeah.
All right.
Yeah, I would say you don't want to wait for the next IETF. So yeah, just send an email to the list, and hopefully a couple of people will sign up.
Excellent.
Yeah.
Now, this is a fun can of worms. TE ARC. Last call, review's done. Now, if it goes to T's review again, are we going to get kicked back on the acronym? What has happened to the acronym police? Are we stuck now thinking that we can or can't use TE? I think the argument just kind of fizzled. And is T's going to kick it back? Alvaro, do you remember what happened with the acronym police?
Yeah, so it's not the acronym police, it's the consistency, made sure that we're talking about the same thing everywhere, people, not police, good reviewers, I'm going to call them for the record here. So I think that last time I talked to Deborah, if I remember correctly, I think we can move over. Still using TE to mean something else. Tree, I think, is what it means now. It's not the best, but I think we're good to go.
Okay.
If
I think it means Corliss Eckert, isn't it?
I'm sorry?
I think TE means Corliss Eckert now.
As I said, not the best, but we need to move on. So I think we can move on if there are other issues that Deborah wants to bring up. We can see those in IHG review and deal with that there.
Thanks.
Can I just quickly comment?
Yes, please.
Yeah, I mean, in the review from Deborah and Lou, I brought out the arguments that there is sufficient pre-existing evidence that there is no consistency, that there is overloading of these things, and that it's well explained, and that we're doing something that the Unicast folks haven't been doing, so that their pushback is not taking into account that we're doing something different. And there were no other responses to these arguments. So if during IETF review other people want to bring up the same argument, I'll have the same responses, and I didn't see any pushback on them. So that's why I would say that Alvaro's evaluation is correct.
Great. Thank you, Torres. And congrats. That's a little better upbeat, the review on that. So Bier ping expired recently. We're waiting for the Shepard review. I guess, man, if you're on the call, this is where we start pointing fingers. I know they'll point back at me and us, and we need to move things along as well from that first list, but we do have some Shepard reviews we're waiting on here. So we also have Bier VPN. We addressed all the comments since 106. We're just looking for a Shepard. So I think we exhausted our last group of volunteers that came through, but we can see we've got 3 Shepard requests here of EVPN, HTTP response, and OSB v3 extensions. So if you're looking to get more in depth in this exciting thing of staying up late at night and staring at your laptop with a bunch of people from around the world, honestly, the Shepard process gets you right into the mechanisms of the draft, of the process itself, going through the queue, and it's a great chance to get engaged. So we'll take you to the list. We'll ask for volunteers directly for these three. And then, man, if you can bump these. Yeah.
Greg, then stick. Yeah, give it a break. Greg, then stick, please.
Hey, Greg.
Bier, so Nagendra prepared their new version. We just want to update their contact information for Vera. She's not with Huawei any longer, so we need to confirm that we have correct coordinates for her. And I would expect it to be.
In draft.
Yeah, thanks.
Stick.
Good, Stig.
Yeah, so about the MLD draft, there is a hard dependency on a draft in PIM for an IGMP MLD extension. So I've been waiting
Okay.
on that, but that is going to working group last call shortly.
Got it.
And
Okay.
and I need to do at least a brief update of IGMP MLD draft, but yeah, it could be ready for last call maybe in a few weeks.
Excellent. All right. We'll wait for your update then. Thanks.
Thanks.
All right. Moving on. We have some new drafts. Bier BFD, MBLD, signal over Bier, P and Bier Tether. I think Tether's on the agenda tonight, right? No, as a service is on the agenda. Are any of these? Bier BFD? No. All right. New drafts, but I guess we're not even discussing them. Oh, what a shame. All right. And other docs. So the V6 requirements. It's going to be presented again. This is a cycle. We're going around and around. And I want to say we need to be firm on terms because we're all chasing this round robin of semantics. And we need to be very explicit here. What is encapsulation, what is encoding, and what is architecture? And we'll get into that hopefully tonight in some detail, and we can come to some agreements, and then we can have some plot forward. Let's see, Bier PHP. I guess we've addressed the comments. Maybe it's ready for last call. Anyone read it? We have a chat. That's an old one. There we are. So I guess taking it to the last call will definitely stir the list. People have to be engaged in. Yeah, go ahead. Sorry. All right. And well, that brings us to the next agenda item. Unless someone any more comments on drafts, draft status.
Greg,
Yes.
Greg, the PHP, I think we finished that last call.
Oh, seriously? Okay. Status says it's ready, so I guess we slipped that one through. If it's finished last call, then that means we're waiting for a shepherd. So that's 4 shepherds we're looking for now. So please solicit friends, family, neighbors in lockdown, looking for nothing more to do than read and follow some instructions. It's a quick list of questions to answer, and we can get through these things.
Quick intermission. Alvaro, it is still necessary for people on the mic to say who's speaking, because we know we see these people coming up. And I know who people are. Or are we good with meet echo, people just jumping in and talking?
Let me think what I should say right now first. Alvaro Tanaralingidi, how's that? I think it would be nice. I think the Mineco indication there, you're right, it tells you who's talking of everyone who's green up at the top, so it should be okay. I think in general it's probably fine if we don't necessarily identify ourselves. So it is not mandatory to identify your affiliation or anything like that. But if people want to, it's not a problem.
Thanks.
Another question? Shen? Go ahead.
Yeah. Hello, everyone. Today I'm going to talk about the Bier fast array route. Next page. So basically, Bier fast array route is a fast local protection, which provides fast array route protection for transient node in a Bier domain. So this protection has no per-flu states in the core of the network. So let's look at details. Next page. We know for Bier, and then on each node in the Bier domain, that node has a bit index routing table. So from this routing table, we can derive a bit index forwarding table. So with this forwarding table, so for each Bier package, then we just use this bit index forwarding table to forward the package. So in order to support Bier fast array route, so we should have a fast array route bit index routing table for each label X. So this FR bit index routing table will consider the label X failures. So it has a route for each destinations which get around this X. So from this FR bit index routing table for a label X, we can derive corresponding FR bit index forwarding table. So whenever a node, a label X fails, so the node will use FR bit index forwarding table to forward any Bier package get around that failed node. So let's look at the details next. Next page. So first, we look at details about FR bit index routing table. So on a node in a Bier domain, that node have a FR bit index routing table for each its label X. For example, on node B has 4 labels, A, E, C, and G. So on node B, we can have one FR bit index routing table for node G, which is a label of B. On B, we have FR bit index routing table for C, and so on. So this FR bit index routing table for X will have routes for each egress node without going this node X, because we consider X failures. So for a node to build a FR bit index routing table for label X takes 2 steps. So first we start copying the bit index routing table to this FR routing table for X, and then for each destination with label or next hop X, we compute a backup next hop for X. So this backup next hop is a LFA for protecting against the failure of X. And then we just replace this X with a backup next hop, and then we get a FR bit index routing table for X. Next page. So here we just give examples. So for example, on node B, we have a bit index routing table. So in order to have a FR bit index routing table for C, consider C failures. So first, we just copy bit index routing table to the FR bit index routing table for C. That's the starting point. And then for every egress node, we select hop label C, and then we compute backup next hop for C. For example, here we have 3 destinations D, E, and H with next hop label C. So for these 3 destinations, for these 3 equals node, and then we computer backup next hop for C. For example, for the destination for the equals of D with next hop C, we compute next hop is G for C. So for equals node F, we compute the backup next hop for C is E, and so on. So for 3 C's in this routing table, we compute the next hop for each of them. And then we change this C to its corresponding next hops, and then we get the FR beta index routing table for C, which is the right down corner one. That's the final FR beta index routing table for C. Next page. So after we have FR beta index routing table for every labels, and then we can just derive its corresponding forwarding table using the same procedure as we derive the beta index forwarding table from the beta index routing table. So with this forwarding table, and then after a node detect any of its label failures, it will use this FR beta index routing table or forwarding table for this failed node to forward any Bier package, and then this package will get around that failed node, and then finally to be delivered to the equals node according to the beta string. So next page. So because for sometimes after the load of failures, we don't have any get around way to equals node. In this case, so one option is that we can drop that package. So another option is that we can just still continue deliver the Bier package to the failed node. So I think that the one option is that we can consider this a special case. That's the option. So I think either way it will work. So next page. Yeah, I think that's all about the BFR. So any comments? I would like comments from the people.
Okay, everybody please state his name and association when talking. Jeffrey, you have the mic.
I
Go ahead,
already made some comments on the mailing list, and we had some exchanges. First of all, this is all internal implementation details. That even if you want to write a document draft, it should not be a standard track. At most, it's informational track, and especially the way that you use a separate table for FRR. It's not necessarily the best way to do it. I understand that different people have a different view on that, but if you want to, when you write a draft about it, you certainly want to document the best solution. But I don't think we can reach consensus that if this is the best solution.
Yeah, I think I also let me give my opinions. So I know this we can have multiple labels or multiple tables, and then we can just combine multiple tables into one table. So I know for the IPFRR, because for IP we have a very big table. So in this case, if we don't combine multiple tables, and then we'll waste a lot of memories. But for this one, Bier, the table size is very small. At most, it's the number of nodes in the network. So in this case, so we can see that if we use different separate table, it's logically very simple. We generate or maintain these tables separately. It's very logically very simple. And the only thing that we may consume some extra memories for those space we don't use. So
again,
logically, I think logically the same. Functionally, either we combine multiple tables into one, or separately, logically or functionally at the same. Because we have, for this special case, I think use separate table may be simpler logically for maintenance or whatever for implementation.
well,
So, Stig,
that's
you got a
one
question?
internal implementation details.
Yeah, right.
Okay, Stig.
Two comments. One is, how do you detect that the node is failing? Do you rely on the IGP, or do you have some other mechanism?
You mean detect the failure?
Yeah.
Or detect failure, I think we depend. That's not depend on the routing, because routing is too slow, and normally it should be use BFD or whatever detection mechanism is in the milliseconds. It's faster.
Okay.
Faster one.
Right. Okay. My other question is, how does this compare to using the IGP fast reroute? Right.
Yeah, this is basically this is IP is application of IPFR to the Bier Bier. For example, here we compute a backup laptop. Those backup laptop is the LFA for that failed node.
Right, but the alternative, it would be slower, I guess. But the alternative would be to wait for the IGP to recalculate and basically give you a new next hop, and basically recompute your forwarding table.
Yeah, that's right. So firstly, we will compute the backup based on the current topology, and then after failures, and after IGP converge, and then we will compute the normal routing table, and then after that we'll compute the FR table again. So that's is a loop there.
Right. So, yeah, Stig, you're going to reply to that? Or
yeah, it's a little hard to explain.
No, I know what you're getting at. We got a race condition here, and there's a layer issue I'm quite concerned about.
Yeah, because you.
So this is very similar to IPFR, right? So
I know. But if you have IPFRR, Bier doesn't have to worry about reachability. Bier can just be forwarding, and you fine tune your IGP so that the Bier table gets updated after convergence. Having the IGP converge and then trigger the FRR calculation seems like just adding a layer of complexity and potential race condition. Now, I'm not saying the mechanism itself is not valid, but architecturally, it seems like this might not be the best place to do it when it's already well crafted in the IGP and becomes a single point of optimization that Bier can then write on and benefit from, rather than trying to reproduce.
Yeah, I think that's a good question. I think Jeffrey Zhang gave a very good comment on the list. So Jeffrey Zhang mentioned that in the architecture, I also replied that one. In the architecture document, they mentioned that we can use any unicast fast route to Bier, right? So this draft is about apply IPFR to Bier. So that's this draft is well fit for the architecture, right?
Again, that is, I think, mischaracterizing what the architecture is saying. Now, to use that document to justify this draft is a mischaracterization. The draft should be able to stand on its own, because the architecture is saying that because Bier's forwarding table is built on the IGP, the results of the forwarding table of the IGP, that any benefits that the IGP gains, any FR mechanisms that are already there in the IGP, Bier will benefit from. That doesn't mean it needs to reproduce them.
So
right?
let me jump.
That's the intent of the architecture text. Now, that aside, it doesn't mean the draft can't go forward if you think there's some motivation and the group wants to take it. But don't use the architecture document as a justification, please.
So, Greg, I'm jumping in here. So the IGP is one solution. The architecture does not say it's the single possible solution. I mean, nothing precludes in Bier architecture a controller from installing the tables, right?
Right.
So here's my observation to the draft. First, don't overspecify, don't go into so many implementation details, right? This is all very vendor specific, it mostly backfires. This kind of drafts where you start to, specify an implementation in a lot of detail. You can give an example, okay, but focus more on architecture. I see a use case for it if you don't have an IGP, right? Because then you don't have FRR. IGP FRR works beautifully. I mean, implementations are there. We know it kicks in. Bier just runs over IGP FRR, works like a charm with the 50 million. Now, if you want to solve the use case of a controller without IGP or something installing the tables, which doesn't have the benefit of IGP computing FRR, the problem you need to solve is how to manage and synchronize the PQ space, right, between different routers, because everybody has to agree that they are supporting this. Now, what is confusing, your draft is basically specifying IGP extensions to do that. So it would look to me very weird if you ran an IGP just to signal a PQ space and not use an IGP FRR to provide FRR. So think through the issue, how will you make sure that everybody's synchronized in the same PQ space? But I think it has certain architectural lags. It's right now, it's a overspecified draft with too much implementation, and it is confusing because it uses this IGP for signaling, at which point in time I don't think there is a use case for it. Thanks.
Yeah, second, this draft don't have any IGP extensions, right? For this BFR, there's no IGP extensions, none.
Oh, sorry, did I confuse it with another draft? I thought that you had OSPF extensions. Then I'm
No.
awfully sorry. But then how do you know that all the routers support that? Because everybody needs to pre-compute it if you're taking an LFA.
So for the LFA RFCs, so just basically in general, IPFR is local decision. So if we look at the IPFR RFCs, IPFR RFCs, they declare that every node is local decision. So there's no protocol extensions regarding to IPFR either.
And that will hold for Bier, because maybe I just went off the track, because I thought in Bier, if you have this alternate table, that the LFA node has to take the alternate table. I may be off the track. Okay, then I'm awfully sorry. Then I take it back, if you don't have IGP extensions. I read
Okay, no, this one, no IGP extensions.
Okay, good, yes.
Jeffrey?
Want to clarify that because Bier forwarding is based on the unicast forwarding, so whatever you have for protection for unicast, whether it's IGP, IPFR based, or even whatever BGP based, whatever, or controller based, whatever you have for unicast, you can just use it for Bier.
Right.
And you really don't need any further extensions. So this, at most, you can write the informational draft about it. And there is already a draft about FRR, and it was presented a couple of times as well. If you want to proceed, you can check with the author of that draft and then see if you can produce a combined document.
Yeah, that's good. So for that draft is also called the BFR, but they use different approaches. I also reply on the mailing list. So that FR use tunnels to the lex hop. So that is different from we just use the IPFR.
So we got.
Does not matter how you use it. It's whatever you use to protect a unicast path to a BFER, then that can be used for Bier. So it does not matter which whether it's tunnel based or IPFR based or whatever. You can.
It
Yeah, that's different. If we tunnel based, we need to set up tunnels, right? So this one we don't need to set up tunnels. That's different approach, different method.
Right. That's the point. If the IGP is doing it, Bier benefits from that already. So we have another question, one more at the mic. Unless Jeffrey had more, we had to move on here. We're 5 over. Shane? Jeffrey, do you have something? There we go. Go ahead.
Sorry.
Go ahead, your turn.
Oh, okay, thank you. I remember last time there are
Please.
some very excellent tests about if we introduce Bier FR in the Bier mechanisms, there are some benefits rather than reuse the IGP FR mechanism. So I think that will make sense.
I don't understand. Where was this set as benefits? I'm lost.
What
I
are the
mean,
benefits?
last time we have a test showed in our working group, right? I think from the university and from the authors of the other FR drafts. Do you remember? And in their test results, it shows that if we introduce Bier FR rather than reuse the IGP FR, the time will be much faster. So I think it will have some benefits considering how fast it reacts. That is the
Excellent.
point.
Got it.
Mm-hmm.
Thank you. All right. There were questions. Time to move on. Let me get this rolling to the next piece, which is 1, 2.
Sandy, you have a comment, but we have to move on.
Yeah, go ahead, Sandy.
Name, affiliation, everyone, please.
I will do a quick comment. In my opinion, this draft doesn't introduce any new function for the IPFR. So it reduces the IPFR function to make it as the Bier FR function. So I don't think this introduces any new in IPFR. So because Bier inherited the IPFR advantage from IPFR, so I don't think it's needed. That's my opinion. Thank you.
Well, again, architecture does not describe that you must run IGP. Okay, let's close that. The next person who doesn't give me name and affiliation will end up on the call button. I have the atomic bomb. Thank you.
I'll give you a name.
So this one, I talk about the Bier egress protection. Next page. So Bier egress protection provides a faster protection for egress nodes in the Bier domain. So this egress fast protection will not have any per flow states in the core of the network. Next page. So for egress protection, so normally we have we have a multicast tree. So this is multicast tree is indicated by the bit strings. For example, we just consider the multicast tree have one egress node D, and then this D as an egress node will send the multicast traffic to receiver CE. So consider this one egress node. Multicast tree maybe have multiple egress nodes. We just consider this one to explain the egress protection ideas. So in the normal case, so when C receive a Bier package to D, so it will deliver package to this egress D, and D will deliver package to receiver CE. So in order to protect failure of this egress node D, so first we need to have a configuration on this node D, configure a backup egress node to protect this egress node D. For example, here for node D, we can configure node H as a backup egress node to protect the D. So after this configuration, this egress node will distribute the information about the backup egress node H to these direct labels. Here, for example, in this diagram is C and G. And then after the label of D receive this information, it will create or build an egress protection forwarding table for D. So this forwarding table will deliver the traffic targeted to D to the backup egress node H, which is configured. So in this case, whenever C detect the failure of egress node D, it will use the egress protection forwarding table for D to deliver the package target to D to the backup egress node H, and then the backup egress node H will deliver the traffic to the receiver CE. So that's the basic idea of the egress protection. So next page. So here we just give more details. How do we have the egress protection routing table, and then from egress protection routing table, and then we derive the forwarding table. So for protecting, generally, in order to protect egress Y, and then each label of the Y will have an egress protection routing table, and then for Y, and then from this egress protection routing table for Y, and then we derive the egress protection forwarding table for Y. This forwarding table is this routing table for Y. So to build this egress protection routing table for Y on a node is easy. For example, first we just copy the normal Bier index routing table to this egress protection routing table for Y, and then for every egress node Y with label Y, we just add backup information. This backup information, which is in fact just the backup egress nodes for this egress node Y. So use this backup informations when the label of Y detect the failure of Y, and then that label will use this backup egress node to deliver the packet to egress Y to the backup egress node. So next page. So here we just give an example to build the egress protection routing table, and then from this egress protection routing table, we derive the egress protection forwarding table. So here on the node, we consider protected node D as an egress node, and then the label node C is the label of D. So on node C, we'll create an egress protection routing table for D. So this table, the egress protection routing table for D, we start from the normal Bier index routing table. So from this starting point, and then we just consider the egress node D with next hop is also D. So for this forward entry, we add the protection information. So for example, here we just add the protection information is that this node D as an egress node is protected. We use a flag egress protection EP equals to 1, and then we have the backup egress node ID. So here the backup egress node ID for protecting the egress node D is H. So with this information, so we can forward the package target to D to its backup egress nodes when D fails.
So Tony had a question. We have someone on the mic.
That's where I get confused with the other draft, because here you're signaling the protection. So my question is, why does not normal FRR work here? I mean, you signal protection in MPLS case on EPE, but that's because you need special labels. You don't need any special labels here. So either normal FRR works here and you don't need any signaling of the backup, or otherwise it doesn't and the other draft doesn't work. So that's what confused me between the two drafts, why you signaling.
Yeah, this one, because we signaling is that it's just notify the backup egress nodes, because IPFR don't provide protections for the egress node. So for egress node, we need a special handling.
Okay, did I lose an assumption? So CE does not run Bier, or does it run Bier?
No, C does not run Bier. The C, for
okay,
example,
fine.
C is the
Okay,
domain, right?
All clear. Thank you. Yeah, I missed that assumption. Thank you. Yes. Okay.
Jeffrey, you're next.
So I also made comments on the email list about this one. First of all, minor point is that they have separate the egress protection table. It's not necessary, but that's again, that's implementation detail. The main concern I have is that according to the draft, when C redirected the package that was destined to D to the protection node H, C will actually turn off the bit for D, but turn on the bit for H. And that will that is not good. And if there is a receiver of H will that receiver may get duplicate packets. So I also in the email I mentioned that the tethering drafts can be easily extended to handle the egress protection. It's actually the same. It's a natural extension of the tethering concept, because the tethering is to have a helper node to help a node that does not support a Bier. Here, if a Bier node fails, you can think that okay, I can have the helper node to deliver traffic to the to the CE. So I think that solution will be much better.
Yeah, that's arguable, because for this one, so if we have a good planning, so for each egress node, and then we configure backup egress nodes, because in the normal situation or in the normal operation, the traffic only delivered to the egress node. The traffic will not deliver to the backup egress node, right? So only the egress node fails, and then we deliver packet to egress to backup egress node. And then that backup egress node will deliver traffic to the receiver. So that's more efficient. So if we have a good planning, so that in that way. So I know your case is that, so if we have a mixed configurations, so this egress node and the backup egress node, they'll mix up, then that will have some case, as you mentioned, we need to have tunneling, and then we also need to remember the primary egress node bit, and then on the backup egress node, we check whether this is for the primary egress node. We don't have duplications. That's only. So I think that your proposal in the main list for filtering extension is some kind of improvement on this egress protection, because this one covers some basic cases, and then for some other cases, complicated cases, and then we need those extensions as you mentioned in the mailing list.
The tethering extension will cover all the cases.
Yeah, that depends. I know, because for example, this one so we can look at details, whether you cover all of them, or we can go to details and discuss on the mailing list.
Yeah, we can discuss on mailing list. Yeah.
All right. Well, yeah, we're getting behind, so let's move on. Next slide.
Yeah, next slide. Yes, this just give examples how do we derive the forwarding table from a routing table, and then after we have a routing table, and then as soon as we detect the failure for the egress node, the neighbor node will forward the traffic using the egress protection forwarding table for that egress node, and then deliver traffic to the backup egress node, and the backup egress node will deliver the traffic to the receiver CE. So next page. So this one just some updates for the forwarding procedures. In the forwarding procedures, so we will consider the protection. So when a node when egress node fails, and then we don't have a path to that egress node, and then we have protection informations. So if we have protection information for that egress node, then we'll check egress protection EP is 1, so that means that egress node is protected. Then in this case, we just clean the bit for that egress node K, and then we use the backup egress node, and then we just add the bit for that backup egress node, and then we just run the process again. Then in this way, the package will deliver to the backup egress node, and then backup egress nodes will deliver traffic to the CE receiver. Next page. Yeah, that's all about. That's roughly about the egress protection.
All right. We've had a lot of good comments already. Anyone else at the mic? I think we got some good discussion on the list. Jeffrey, thank you very much. Let's keep that that conversation going. Anyone else want to take the mic? We go on to the next document. All right.
Okay,
Next
thank
it
you.
is. And the next being as a service. Is that what next? Yeah, as a service is next. All right. Excellent. All right.
Okay.
Take it away, Jeffrey.
Okay. So this is a review of this multicast and Bier as a service. It was actually presented the first time in Bangkok 2 years ago. Now here we are again virtually in Bangkok. Next slide, please. Basically, this is stable, and we believe it's ready for working group adoption. We want to seek comments and seek a working group adoption. So for today, I only have 2 slides for quick review, and then all the slides from the IETF 103 are included in the at the end for references, but I will not present those slides. Next, please. So basically, because Bier does not require per flow information in the network, so now an operator can start provide multicast transport service to its customers in a very scalable and simple fashion. And this is a simple example. Well, it's not simple. It's a single operator example, many ASs, and it has BFERs all over the places. Now, this operator can start with only BFERs and no BFRs in the middle. Just start doing Bier, but that means that you're essentially doing ingress replication between the BFERs, but that's fine. And you can gradually add BFRs at strategic points. For example, in the middle, ASBR23 and ASBR24 in the AS200, you can turn Bier forwarding on those 2 ASBRs. And then you can use tunnel encapsulation attributes to steer Bier traffic along the Bier capable routers. And then let's say that later on, you start most of the routers in AS100 or in an area in AS100 can start supporting Bier. Then at that time, you can enable Bier in that AS or in that area as well. So whenever you need to go through some routers that does not support Bier, then you can use tunneling, and any kind of tunnel will work, whether it's MPLS, GRE, or IPv6, whatever, any tunnel will work. So for this to work, we will use BGP-based Bier signaling, especially when you involve this multi-AS situation. And when you have a native Bier forwarding in AS or in an area, you use IGP signaling. And you can distribute Bier information between IGP and BGP, and we already have a working group drafted to cover that redistribution. Notice that even though this is multiple AS, it can still be just single Bier subdomain, and initially you don't need any segmentation. You can, if you desire, introduce segmentation incrementally. Next slide, please. Now, the same topology, but imagine that AS200 in the middle is actually a third-party provider. It provides Bier transport to its Bier customers. In this case, that's in that for that provider in AS200, it does not have even have BFERs. It only has BFRs. No customer SG states, and in fact, this third-party provider can have many customers, and each customer can have their own Bier domain. And those Bier domains can have conflicting subdomain IDs and BFR IDs, and this can still work. Basically, when we signal the Bier information, you either using BGP or IGP, we can introduce a route distinguisher to signal different information for different Bier subdomains. All the details are in the draft and in the slides at the end. So I will have to skip those details for now. Next. So the key point here is that this solution is stable. We believe that it's stable. It's well specified, where we would like to seek comments and work group adoption. Thank you.
All right. Who's read the draft? Give you a few more seconds here. We have some admitted readers. We have an admitted non-reader. All right, we've got a handful of people who've read the draft, and that just sets the room. We don't have a lot of participation, unfortunately. So next one is adopt.
We have people on the mic that's still current. First person on the mic, please, affiliation and name.
Mike. Actually, as I remember when we discussed about Bier IPv6.
Okay, next one on the mic. Affiliation and name, please.
Oh, it's on the mic. Cannot be heard.
Yes, I cut off your mic because I need, please, to know who is speaking or whom you're affiliated with.
You need to state your name and affiliation to begin.
I have already indicated that. Can you hear me?
Yes.
Yes, I have already indicated that, but maybe my audio is not so good. This is Juesong on the mic, and my comments is that, as I remember, there are some previous discussions in the mailing list about when we discussed about Bier IPv6 requirement, and it is said that inter-AS domain is not in the architecture of Bier. So I'm wondering, is that this work is about that topic? I'm interested in this just to make sure whether this is inside the charter or architecture or not.
Again, I think we're slicing semantics of the charter, because in the idea that we would have multiple IGPs being multiple domain, and here we have to depend on that and extend is not what is actually being discussed here. This is a single, basically, reachability domain as an overlay. So because it's an overlay, it's going interdomain, but it's not necessarily hop by hop interdomain solution with Bier. I mean, ultimately, because it's an overlay, and Jeffrey, I got a lot to share with you as well. I should take some of this in the list, but we've explored a lot of things. Because it's an overlay, there is no physical topology you need to adhere to. You can do whatever you want with it. And now your forwarding table is basically yours. And the FIB can be identical. The only thing that changes is the packet. So there's a lot of opportunity here if we don't get mired down in this idea that we're doing hop by hop. Hey, Guyan?
Yes. Yeah, this is Gia. Can you hear me?
Yes.
Yeah, affiliation Verizon, right?
Yes, with Verizon. Yes. Yes. Thank you.
Thank you.
Yeah, so the question, it was similar to the previous question related to the NRAS, and I was kind of curious how that would work. But as Greg, you mentioned, it's an overlay. So there's the inner domain, the boundaries, I guess, are really kind of, there's really no boundary here. Actually, you can really extend the tree really anywhere. And that was really the question. And I guess what was also mentioned was, I think in one of the slides, mentioning like a route distinguisher and maybe doing like RT translation, or in the draft, reading through the draft, I glanced through it, but it didn't really go really deep into the details of how the interdomain, and like if there's here like translation happening, on the layer 3, and that's more like BGP, like an IDR or BES type question. Now how is that piece of it working? But there seems like there's a lot of inner workings with the IGP and BGP that happen that are behind the scenes, I guess.
Well, I would like to hear more from you on
Jeffrey, name and
offline.
association every time, please.
Jeffrey from Juniper. Yeah. So yeah, again, we can follow up on the mailing list or offline on the details that you think are missing.
Okay.
Yeah, and yeah, and Greg, I'll follow up with you as well. And Jason, for your initial question, I would like to get a reference to the original email that you were referring to. I don't think that this is related to that, but let's follow up.
40 minutes. Do we have an option called standing, or we don't? We move it to the list for further discussion.
Right. Let's go to the show of hands tool. We have 5 say it's ready for adoption, 1 says it's not. So that's enough for us to at least take it to the list, and we'll see how the rest of the crew responds.
So we take an adoption call to the list, or we take the discussion to the list?
We take it to the
Because it was
list.
clear, right?
Well, we have to.
What are we taking?
The adoption.
Okay.
And we got Jeffrey again. So let me get your doc back here, Jeff.
Gian, you still in the queue, or you no further questions?
Sorry, let me remove my hand. All right, there you go. Thank you.
No, don't do that. And transport. All right. See it?
Okay. So this is about layer independent fragmentation or IPsec ESP function not done at IP layer. You notice that this right now it's for the TSD transport area working group, but it's got a use case in Bier, in MPOS. So I'm presenting here for the use case as well. Next slide, please.
Important, Jeffrey. So this is targeted at another working group, or where will you seek adoption for it?
It's already in TSP.
So the use case can be in Bier, in MPOS, in BES, but actual work for let's say we standardize it, whether that happens in TSV or not, we don't know yet. It's
okay.
Subject is open. Yeah. Okay. So let's start with the observation that with EVPN using MPLS, if the PE receive a packet from Ethernet frame from a CE, and that packet is too large, and today the only way to get it through the underlay is you use IP encapsulation first. So you put that Ethernet packet into IP, and you fragment the IP.
Uh-oh, we lost him. We lost his audio. Did we lose him entirely? Nope, he's still there. We lost your audio, Jeffrey.
How about now?
There we go. We hear you.
Okay. Okay. So today, the only workaround is to use IP encapsulation. You first impose a service label to the Ethernet frame, and then you put it in the IP. You fragment the IP package, send that across, and then on the other end, you reassemble the IP package, decapsulate the IP, and now you see that your service label. Then you know where which bridge domain this packet frame belongs to. That works, but notice that here MPLS is only used for service label. It's not used for transport at all. And there are operators who do want to use MPLS transport. And in case you use IPv6 encapsulation, you're having a large IPv6 overhead. So the need for fragmentation is actually not new. In fact, pseudowire and VPLS sort of has a solution for this that is documented in RFC 4623. They use control words. Inside the control word, there is a sequence number, and that can be used for fragmentation and reassembly. However, that does not apply for EVPN. Because EVPN either does not use control word, or when it does use control word, it's all zero. It does not use a sequence number. And additionally, in case of pseudowire and VPLS, the fragmentation and reassembly is done in the context of each pseudowire. But with EVPN, you don't have the pseudowire anymore, so you cannot do that. You cannot use RFC 4623 method. So the second observation is that IP fragmentation can actually be viewed as independent of IP, as long as that identification field in that fragmentation header is available. Today, in case of IP fragmentation, you use the IP source and IP destination address as the context. In fact, the source address itself is enough. You don't really need a destination to be the context. Next slide, please. So the proposal is that we support independent fragmentation and reassembly function in a shim layer. So in that EVPN MPLS example, now the ingress PE imposes the service label and then the fragment package. Now notice that this is without doing IP encapsulation first. We use a generic fragmentation header, and the next header value in the header says MPLS to indicate that following that the GFH is the MPLS payload. Now, compared to the IPv6 header, the main difference is that now GFH has additional information about the source. We'll come to the details later. So the ingress PE will impose the GFH label to indicate that after this GFH label, there is this the generic fragmentation header that follows. Then it imposes the transport label and send traffic. Now, the egress PE gets the traffic, sees the label that identifies that GFH follows. It reassembles the package and then hands over to MPLS for further handling because the next header in that GFH is MPLS. Next slide, please. So this is the information about the fragmentation header. At the top is IPv6 fragmentation header. It starts with the Lex header, reserve field, fragment offsets, and the identification. That identification basically says is a number that's assigned for a pre-fragmented IP packet. So all the fragments of that fragmented IP packet will have the same identification number. And that identification number is in the context of the IP source destination address. Now, for the generic fragmentation, we will start with 4 0 bits, followed by the next header, followed by the header length, and the identification field is a variable. The reason is that in some cases, we will embed the context of the identification number in the identification field itself. So the identification field is a variable field now, so we need a header length. And that's S bits before the N bits will indicate whether the identification field has the context embedded or not. Now, the reason to have that 4 0 bits at the beginning is to handle the ECMP issue. If we don't have that 4 0 bits there, when the packet goes through a transit router, and that transit router is doing ECMP hashing, it may think that this header, GFH header, is IPv4 or IPv6 header. And when it does ECMP hashing, you may get a packet ordering issue. And that is, if you have read this draft closely, you will notice that that 4 0 bits there were not in the draft itself, but Stewart brought up this ECMP issue and made comments on the mailing list. So we are adding that 4 0 bits there. Next slide, please.
Jump in, Tony here, because we had this precisely the same nibble problem with Bier, right? You have to think through that the stuff is not being confused for V4 or V6 and whether any silicon will do funky stuff with all zeros. That's why you have 0, 1, 0, 1 for Bier, right? So it doesn't get forgotten. Yeah, thanks.
Okay. So this slide I already talked through. So next slide, please. So coming back to the motivations, this will solve the EVPN MPLS fragmentation problem without incurring IP overheads or requiring IP transportation. We only use a fragmentation as an example, but other functions like encapsulating security payloads that can be done similarly as well. In fact, this fragmentation and EST function can be applied to Bier as well. And Bier encapsulation has a protocol field, and that field can be used to specify that the payload after Bier header is a GFH header. And in theory, if you assign either type for GFH, then you can even do fragmentation for Ethernet frames on a pure layer 2 device. That is just in theory. If IEEE thinks that that's a good idea, they could do it. Same idea. So this is a generic solution that works for all layers, whether it's MPLS or Bier or Ethernet. And even though right now it's mainly for EVP and MPLS fragmentation problem, it can be used for pseudo-wire and VPLS as well, where you have one solution works for all the layers for all the situations. Next slide, please. So basically, we see comments. We are presenting this and having discussions in the BAS, MPLS, Bier, POW, and TSV working groups. And we will need to find a home, whether it's the use cases are certainly in BAS, MPLS, and Bier. But if we decide to take up the work, then the design of this solution, a standardized solution, whether it happens in TSV or in internet area or some other working groups, we don't know yet. That's open for discussion.
So this is
Okay.
Greg, independent, prompts AI. So did you present this, you said, in TSV?
TSV Kriti presented, it was just one slide because they were prioritized on working group documents. For this new document, they only gave one slide time.
What? I didn't understand that. There was a what?
So the TSV session was on Monday, and
okay.
they were focusing on the working group documents, and for this new individual drafts,
Got it.
they only allow one slide. And
Got it. All right.
They
they were too busy. Got it. All right. Was there any feedback Kriti get that was either direction of interest?
Well, I actually missed that session because at the time I don't think there was any discussion there. But in MPLS, there were Stuart brought up a lot of comments and especially point out the ECMP problem. So we do have a proposal to solve the ECMP problem.
Yep. Excellent. Good. Very interesting stuff here, Jeffrey. Thank you. Any more comments? I mean, I assume the expectation is that we'll be living here, but it's definitely stuff we should be paying attention to and help move along. Go ahead, Tony. You said something?
No, I'm just watching the queue. I mean, when I saw the original idea, I share your sentiment. Yeah, this could, solve a lot of problems with one single swoop. Yeah, that we were piecemealing all over the place. Yeah. Pseudo-wire was a nightmare in this respect.
All right. Thanks again. Next is B6 requirements draft. Into this.
All right. Hi, my name is Guion Mishra, and I'd like to review the Bier IPv6 requirements draft. On list, I know a lot of folks are familiar with this. It's been around. It's been, I think we're going on close to 2 years with this draft. So next slide. So what I wanted to do today, I did on this with this presentation, is really just go over the history of this draft and really some background. I kind of came into this, in the middle of the summer, so I don't have complete history of through the mailing list of just what I've scraped as going through the mailing list historically. But so this slide, what I did was I just went through and I scraped all the drafts. And really what I did was look at the table of contents and and really the one contentious item that came up, and it was through the end of the summer, and then we made some changes at the request of the work group chairs and the, sorry, if you could stay on the last slide. Sorry about that.
Oh, I'm sorry. I was reading. I keep forgetting you're watching this.
No problem. Yeah, so what I did was so I know there was a debate about the solutions. So I wanted to bring this up. So the solutions, and really what happened, and I talked to Jeffrey Zhang about this a little bit, and I think he gave me some feedback on I think from the original solution. There was one solution that came out in 2017, and that was the Bier solution, Bier and 6. And so that was the original one. And then early in 2019, a second solution came out, which was an integrated model, the Bier V6 model. And then shortly after that, this draft came about, the requirements to come up with, a set of requirements, because we had one and then a second came, and then really trying to determine, well, do both drafts really meet what the requirements are? And that's where this all came about. So we started, basically, it's May 2019, and now we're about a year and a half later. We're at the end of 2020. We've gone through 10 revisions. And so through the 10 revisions, we have had the solutions in there, but I think really the focus after this last revision, since from revision 0 through the revision 9, we had both solutions in there. Either they were in the body or in the appendix, but they were in the draft itself. Just in the last revision, we did remove it. So we removed it at the request, and I'm completely on board with it. And we have all the authors on board that we want to focus. We want to get through the requirements, and the goal is to get this down, get this set, get whatever we need. We want to get it done, and then move on to the next steps. So with that, let's go on to the next slide.
Yeah, just Greg as chair, just to refresh on what happened on Rev 0, where Rev 0 came from. When the first NCAP draft came out, let's call it an ENCODE draft, it wasn't clear what problem they were trying to solve that wasn't already solved with many of the existing tools that were out there. And so as that conversation does its normal spiral out of control, we said, let's just start with a requirements draft. If you lay out what the requirements are, what we're trying to solve, then we can better evaluate the actual solutions and then come up with something. Later, the other draft, the other solution came around. But the requirements draft came from just the inability for the working group to really understand why new tools are needed here.
Understood. So that's a good correction that you said. So the requirements draft actually, so we had the first model, and then the requirements came up to really, so we're all kind of marching to the same page, really in sync. And then and then came the second one. Gotcha. Thank you for bringing that up. So I'll help clarify that.
Thank you. Someone else to the mic? Jason?
Thank you for GN to summarize the history. Actually, I'm not sure why we use new solutions to describe the encapsulation solutions. I think both solutions are they are doing things and defining new things, and I cannot say something is inside the existing toolbox and something is not. I think there is no such conclusions before. Just one comment, and I'm okay with the other conclusions here.
Thanks.
Greg, can you summarize that?
I didn't catch everything. Yeah, Greg, if you caught everything she said, I didn't catch everything.
Neither did I. I don't agree with the comments.
Yeah.
And again, name and affiliation every time, please, because there are people who are pure audio and they cannot follow otherwise.
Right.
So what was the comment?
Why don't you state it again, rather than me rephrase it for her? She's still on the mic.
Okay.
Go ahead.
Sorry, Amy?
Jason, go ahead. Why don't you restate it? People didn't quite hear what you said.
You mean just repeat my comment here?
Yes, please.
Okay. I just want to say, I don't know why people just classify these two solutions. someone we describe it as something new and someone is traditional and inside the existing toolbox. I think there is no solutions here. We just all these two solutions or existing solutions are new for Bier IPv6. So I think that is more reasonable if we try to describe these two solutions or existing solutions. And I'm okay with all these histories and summaries. And thank you for GN's work. That is the comment. Thank you.
Thank you.
Okay, thanks. Mhm.
Thanks. I guess we can go on to the next slide if no one has anything else. Right. So this draft, so the purpose of this draft is to specify the requirements for transporting packets and Bier headers in an IPv6 environment. And the focus is really on requirements. So I think as the chairs and AD had requested to remove the solution, so I think we, the authors, we've agreed to remove that. And I think now we're really kind of razor focused on the requirements. So we want to get through that, get that nailed down, and that's really the goal. So we want to help the Bier work group come to really a conclusion, and with the requirements, we had two sets that we broke up through the revisions, the mandatory set and an optional set. So we really want to get that nailed down, so get that finalized so that we can move forward to the next steps. Next slide. Okay. There we go. So what I did was I broke up the revisions. So revision 0 through 4, they had some commonalities. And then revision 5 through 9 had commonalities, and the commonality was version 0 through 4. It was all one set of requirements, and we didn't have mandatory and optional. And then revision 5 through 9 had the breakup of required and optional. So as you can see, we had a bunch of initial requirements. I guess 0, 1, 2, 3, 4. Most all of them were all within each one. So we had layer 2 agnostic, HVH destination option, layer 4 inspection, multicast address in the source address field, SA field, incorrect bits, support of Bier architecture, conforming to IPv6 specification, support simple encapsulation, SA filtering, support IPsec, support fragmentation, hardware fastpath, and then support IPv6 security. Next slide. So as we evolved, we can see through Rev 5 through 9, some of what was in Rev 0 through 4 dropped out. And we'll go through the mandatory. And then what I did was I kind of gave the notation, 5, 6, 7, 8, 9, whichever requirement was part of that draft. So layer 2 agnostic, so that was in 5 and 6. And then shortly after that, after that in Rev 7, it dropped out. Various layer 2 link types, so that stayed all the way through. So that was 7, 8, 9. Support of Bier architecture, that was an important one, and that kind of stayed from 5 all the way through 9. Conform to existing IPv6 spec, that was in 6, and that dropped off after 6. Support of deployment of non-BFR routers, so that was an important one. And that was in 5, and then it remained all the way through to 9. Support of inter-AS multicast deployment, that was in 5 and 6. And there was some chatter on list, and then that ended up dropping off as a mandatory requirement. Support of simple encapsulation was in 5 and 6. Then support of deployment security, that was in 5 and 6, and then it dropped off. And then support of OAM. So that was in 7, 8, 9, and it remained in the final. Moving on to optionals, we had support of MVPN, so that was in 5 and 6, and that dropped off after that. Support of OAM, actually, sorry, that's a replica. Support of IP6AH and ESP, so that was in 5 and 6, and then what happened was we removed AH, and then it went to ESP. Since the ESP has been the industry standard, and I think that may have been one of the reasons removing AH as even an optional requirement. So 7, 8, 9 carried on with ESP. Support of fragmentation, that was important. That was 5 through 9, so that's in the existing. And then the last one is supporting hardware FastPath. So that was in 5 and 6, and then it dropped off. So in summary, I'll just kind of go through like what's in revision 9 today. So revision 9, as far as mandatory requirements, you could stay on that. Sorry, you can just stay on that page. I was just going to read off like 9.
Go ahead.
Thank
Go
you.
ahead.
Yes, sorry. So revision 9. So we got the various layer 2 link types. We have supportive Bier architecture. We have supportive deployment with non-BFR routers. And then we got supportive OAM. And then we have supportive IPsec ESP. And the final one is supportive fragmentation. So out of all the mandatory and optionals that we've had and what we see here, does anyone see any that's really blaringly missing, or something that's in the list that's in number 9 in the draft today that we feel that should not be there, that we can tailor on the call today, and then we can take it on the mailing list? But what we'd like to do is, going through this requirements draft, we want to hone in and try to really focus and try to get this nailed down. Exactly what's there, what's missing, what do we need to do, and get it finalized. So if everyone can really take a good look at what we have. So this is Rep 5 through 9. Does anyone see anything missing that we should add, that was removed, or anything new that should be added? And I'll give it to the floor, I guess. Anyone comments, questions, anyone? Do we have anybody in the queue?
No one's in the queue.
No one's in the queue? All right. God.
Oh, here we go.
Greg and Chuck, do we got? Okay, good.
Yeah.
Good. Okay.
Go ahead, young man.
Hey, yes, Alvaro Retana, routing ID. So since we're walking down memory lane here, I just want to say that the only reason I'm involved in this SAD is because it was brought up to the AESG that the working group wasn't making fast enough progress on this. There's been 9 revisions. It's been a long time. So that's why I went to look at the draft, and that's why I made comments on it. However, the working group is the expert, and you are all the experts. So, take my opinion as a participant of the working group. So when I read this, I don't find, to your question, Gian, of is there anything missing, or should we add anything else or put anything in? When I look at this, I see very general requirements. Support the architecture, make sure it works with IPv6. Well, obviously, right? I mean, this is Bier on an IPv6 network, so these seem to me like obvious requirements. The one about OAM, I've made this comment before. There is no standard OAM solution defined, so I don't see what can be mandatory to be supported if there's no standard solution yet. If there is a future standard solution, that's fine, but and obviously we want to manage this thing as well as we want to manage any other Bier network, but there's nothing yet, right? So I don't see what can be mandatory here. So going back to the main things, right? Support deployment of non-BFR, that's part of the architecture anyways. So it seems to me that this boils down to support the Bier architecture and run over an IPv6 RFC 8200 network. And if the objective, which is what I want to, which is to move on to solutions, and we want these requirements to either help us decide which solutions to move on with, then we need to run Bier on IPv6. And to me, that seems very, very wide, which means that pretty much anything that supports the Bier architecture and that runs over IPv6 could be a solution. Right? In other words, it seems to me like there are no requirements, no specific requirements beyond Bier over IPv6. So that's...
Right. This goes back to the original presentation in the first draft when we asked what problem they're trying to solve. What specifically can't be done with just generic encapsulation, or encapsulating in v6 and sending it over the top?
Well,
Right.
just
And
to be
this, we just chased our tail on this
Yeah.
requirements draft and stuff moved around.
Right. Just, I mean, it's a good point that you bring up, but, I think the big, really, I mean, it's kind of, it stares you right in the face, the elephant in the room, and that is that Bier was there for V4, well, the MPLS and I guess what I'm trying to say is there's the non-MPLS, or MPLS, I guess the original Bier, and then this is really the non-MPLS, which is the IPv6 forwarding plane. So that's really the main really topic of what we have today, which is Bier with MPLS or Bier Ethernet, and so this is kind of outside of that. So non-Bier MPLS doing which implies Bier IPv6, and that's really the framework that we're looking at, Bier over IPv6, and how can we do Bier over IPv6 forwarding plane, and that's really the main construct of it. And then you have
Not Bier over the V6 forwarding plane. That's not the requirement. It's Bier over a V6 network that doesn't support Bier. That's where the first draft came up. And what we made clear from the beginning is we're not going to move forward with a standard that's transitional, right? If the idea is I need to do all these fast things in this, in the forwarding plane so I can get over this box that someday I'm going not to need, that doesn't make a lot of, heavy lifting sense. So that's what we kept saying. What are you trying to solve? What's specifically trying to solve? So you're quite telling when you called the previous solutions V4, because they're not. Bier rides on top of any IGP, and what it needed to do was get from hop to hop. How do we do that? Ether type encapsulation's a long haul. It took us a while to get a traction to get there, but in a core network, it was easy, just a label in cap, and we got it over the top. No Bier information is in the MPLS except the type or the set, and we replicated that with Ether type, so that the header doesn't change and anybody else can encapsulate the Bier packet, which involves the header and the data, and get it across that infrastructure. So with that as part of the architecture, then the V6 came up. And in that, it wasn't just getting it over the top, but it was now not just encapping, but encoding. It was moving the bits somewhere else. And that is a unique move, because we haven't done that with any other forwarding planes. Once the forwarding plane's established, that's the forwarding plane. And then we do things to make it better, and we do things underneath it that it inherits to do better. But we don't spread it around and make the standard muddy. Right? So we wanted to be clear what we were trying to solve before we move forward with the solution. That's my memory of our process here.
Understood. So Greg, just so I'm clear, so I think what really the goal is, I mean, from the requirements and the draft, and I know we've probably gone through like different circles, but really just making sure that we're really lockstep and barrel, with it. It's really, that how really the encapsulation and encoding of how we want to do it, really how, and being able to do that, just supporting, and the reasons why we want to do it. And it's not necessarily that you can do it on an IPv6 forwarding plane. It's more so like, why do you need that, and what's the gap that's being filled, I guess, without it.
But again, doing Bier processing from a signal that comes from the V6 header is not doing Bier in the V6 forwarding plane. We got to be very clear about that. A lot of this has been misdescribed to move agendas along, and that's the frustrating part. There's no integrated solution here. Once you get to the Bier domain, you're doing Bier, right? So same, we don't. When we encapsulate any other protocol, we don't steal pieces from it and make a dependency on another layer. It just doesn't make sense unless we can justify what we're trying to solve. So we have the people at the mic. I think Loa was in the top of the queue there. Anderson, turn your mic on. Are you still in the queue? I guess not. Okay. Oh, we got him. Excellent. Okay, go ahead. You had a question?
Yeah, I was looking at some of the requirement in version 9 of the document. In particular, I'm looking at the requirement that says support various L2 link types. So my question is, when I started out in the industry like 40 years ago, 45, one of the first things I did was actually write requirements. And people told me that they need to be measurable, they need to be verifiable, and if I look at the L2 link types requirement here, it says it should support various kinds of. So I ask, how many is various? Is 2 enough? 5? Does any old L2 technology count, like HDLC or LATB or whatever? So I think the requirements need to be much more specific, and you must be able to verify if they actually fulfill the requirements. And almost nothing I see in that section that says mandatory requirements I'm actually able to verify. Okay.
I think that's a good point.
I think that the 3.1.1 section should say support the following. Or actually, you did go to L2 agnostic in the slides. Is that where you intend to go?
Yeah, so you know what I think, so the layer, so that, I think that was initially there, layer 2 agnostic, and then that was changed to various link types, but then it wasn't specified. So, you know, I think it looks like initially in Rev 5 and 6, it was really independent, so support any, it didn't matter, which was really the agnostic. And then we said various link types, but then we didn't specify. So, you know, I think that may be something that we can, you know, at least specify, you know, which types. And so, I mean, that's fair. We could have that.
So we are tight on time, and I want to make sure we get all the way through to Jeffries at the end here as well. But I think what we're getting here is what we have is mud, right? These things just keep getting moved around, and what we don't have still is a problem statement. What are we trying to solve specifically? So then we can understand what tools are missing, and we can engineer them.
Understood.
All right. We had Jay Hong also. We have one more question, one more at the mic. Let's give him a shot. Go ahead.
Xuesong from Huawei on the mic. Some response to the comments of the chairs. Thank you for your comments. And my understanding is just that it is not so easy to put Bier under IPv6 header. You know, ideally, if Bier want to transport maybe over MPS, over Ethernet, over IPv6, we just put it under the header. But it doesn't work because IPv6, in the IPv6 header, there is next header. Sure, we can define a new next header type for Bier, but if we see the TCP IP structure, we can see there is no places for Bier. I remember when Bier in 6 document is presented in 6.9 last time, the AD told the others that they should get involved transport layer people into the discussion, because if we just make Bier as the next header of the IPv6 header, it means that Bier belongs to transport layer. I think that is not what we want. So the thing is not so straightforward as we think. Ideally, Bier is everything, and we can over everything. But the problem is that is not the case. Why IPv6 designs so many extension headers? It's because it doesn't want so many next header for them. If you want a next header, you just put it in a proper extension header. Just like fragmentation header, security header, it does so. Because
so
actually,
security header and segmentation headers aren't forwarding. Bier is the forwarding plane. We have 3, IP, MPLS, and Bier. If we want to do comparisons in forwarding plane, Use relevant comparisons.
So how about the routing header? The routing header is also for forwarding too. You pick up some segment in the segment list to find the next destination.
Forward on.
That is similar. That is similar. This extension header also influence the forwarding behavior. So that is what extension header for. It doesn't limit
Yes, it
that
modifies the forwarding behavior, but in itself, it is not an architecture of the forwarding plane like IP is. IPv6 is defining itself extending where things are missing. Stuff is missing, you put it in the extension header, right? But Bier is a separate forwarding plane entirely.
Actually, that depends how we understand the problem. If we want to use some multicast solutions, just like Bier in IPv6 solution, so we need Bier. That is what we want in IPv6. Yes, we have unicast. I can use IPv6 header directly, but if I want multicast or replication in IPv6 header, I need some extension headers to know how I do replication
I
and how.
didn't understand what you're saying. If you want to do what? You want to replicate the header? It doesn't make sense.
No. It just means that if I want to do replication and multicast behavior in IPv6 network, I need some extension header.
Network, okay, in an IPv6 network. Then
yes, I want to do Bier forwarding because in some node I want to do replicate and to find the next BFR node. So that is what is missing in IPv6. So I need something extension. That is why we define the bit string in the extension header.
No, sorry, I can't. I'm not going to swallow that because if you're trying to replicate based on a bit string, the functionality is in the box. It's in the router. You can't say it's just v6 if you're doing replication because v6 doesn't replicate. It's a unicast only solution. Putting the bits in the header doesn't make it a v6 solution. All it does is v6 define what the Bier process now has to do. It's still Bier.
I don't understand why IPv6 is limited in unicast. I don't think this is agreed in 6man. And actually, we have already sent our BRv6 to the mailing list and to 6man, and people in 6man think this works. IPv6 can integrate Bier functions.
Actually, what they said was,
replication.
what did the Bier people think?
Yes.
They punted to the replication crowd to get their input. They said this doesn't violate anything v6 would do, but they didn't say anything about replication. That's our job.
Actually, why we cannot do that? I can't see. Actually, it is not forbidden. I think from the Bier side, that what is Bier for? Basically, it's not for MPS only. It's just for bit string forwarding. We just check the bit string and look up in the BFR table and find the next BFR. Yes. Exactly. Why we cannot do it in IPv6 extension header? Yes.
Perfect. So if that's all you want to do, then just encapsulate with the next header field.
But what is Bier next header?
The whole idea of an extension header is to add functionality that you don't currently have. We have this.
Yes.
It's available. It's in the box. It's defined as a standard. In the narrowest choke point of the architecture of the internet, the forwarding plane.
Not really. Not really.
Click on this now and send a conflicting message on where this takes place. It'll never happen.
Not
Are we
really.
done with the
Bier
requirements
is not.
Are we done with the presentation for the requirements
I think because I think that is the main point of why we need the requirement document. So I think the argument is really important here. I think we should continue. And I want to continue my point is that Bier is not naturally the next header of IPv6 header. As I have mentioned, the next header of IPv6 header is transport layer. It's TCP header and UDP header. We cannot put Bier header everywhere as we want. We can do it with MPLS.
What is IP in IP?
Sure, IP in IP, because it is a GRE tunnel. Yes, we can do that.
Okay.
Because they are layer, yes, because they are both layer 3. But for Bier, what we define Bier, we can do it with MPS because MPS it allows that we can put anything
So
above, under MPS label. That is just like MPS label stack. But IPv6 header, no. What is above?
Are we putting any of this into the requirements drafts?
Sorry?
Are we done with the requirements draft presentation?
Right. This is the requirements draft presentation. We need to move along. Thank you, Jeffrey.
Sure.
Any other comments about the requirements draft specifically?
Sure.
No, we're running out of time. We are down to like 10
sure.
minutes left.
Sure. I just think it's important to put our opinions and to put it on the table and discuss it clear. Okay, let's move on. We can continue.
Okay, so next one on the mic, please. Name, affiliation. Next one on the queue.
Then Ben or Mike?
Okay. This one, Greg, in fact, in the SRv6 and also they use the routing header in the IPv6 extension header. There's also the replication segment. You know that this is adopted in the Spring Working Group. They also use the replication segment to indicate the multicast. So the first, this is the first one. The second one, I mean, so that's we know that's the IP in IP, but you know this is for the IPv6 combined with the Bier. I think this because that's the IP in IP because the VXLAN GRE they have this the special integration, but for the Bier in the IPv6, but you know the challenge because the current the existing device they always assume that's the upper layer of this the IPv6 is the UDP or TCP. So if we directly encapsulate the Bier in the IPv6, so I think they may have some the possible risks. So this is just mention this one. So I think maybe it can be discussed in the transport layer to avoid the possible risk and to learn the opinions from the transport layer's opinions.
Or we need feedback from the V6 experts to see if this is actually the case. I mean, because IP and IP works fine. And we have another draft that shows how to encapsulate a Bier packet in a V6 header. So I don't think this is a non-starter as it's being defined. So next is Shihong Gen. Can you be really fast? We've seen this one a lot. I think if it's something new you can go to, that's great, but we don't have time for you to go through the entire how it works presentation. Here we go.
Mike is still on the mic. Pun is unintended. Mike,
yeah, well, super quick. I think it's super quick. Is that the next two presentations, as you just said, Greg, are solutions. So I don't even know if we even need to have them at this point if we're not going to agree that the requirements are set. I mean, we've heard from multiple solutions many times, and it's I just don't know the benefit of that. The point we're at is that we've got several authors who are anxious to start working on solutions in the Bier working group. And if we're, after 2 years, not able to get to the point where the chairs particularly are satisfied with that, then maybe we need to have you guys join us. So we need help because we've added people to the requirements draft. We added Jeffrey, we've added Gian. We're trying to do due diligence here to get going.
Right. And unfortunately, how that began was it was great. You wrote the draft, you presented it, and no one had interest. And we pushed and we kicked, and that's why this time went on for a long time. And unfortunately, the feedback I gave then, I mean, as raw as it was, like if no one's responding, then there's not enough interest to move things along, right? You can't pick people in the room to do it. And you did. You did the footwork, you got more people on, and now we got some traction. But that's why it's drug on. Not because we drug our feet, because the working group just didn't have interest until you finally drew up enough critical mass to get things moving along. So, I agree. Going in these drafts and presenting the stuff right now, but let's get some update first before we do. We have 2 drafts to discuss. I don't want to go into detail about them unless there's new. So is there anything new to present in this draft? Yizhong.
We satisfy all the comments and address all the questions in the mailing list. Yes, we have something new to update because we haven't do the presentation for a long time, so we want to update this to the working group, what we have done.
Go ahead, be quick, please. No, you're going into detail.
So, yes, I won't. People are familiar with the solution, so go skip it. Just use the extension header. Next slide, please. And this one is a brief history of this document. Just as the requirement document, we have the proposal, and we split the document to two parts, and one of them is requirement document. And in version 6, we have some update, and we fix all the concerns about the security, about some other comments in the mailing list. And then we go to version 6, and we have a lot of comments in the mailing list. We address it, and the working group tell us to send it to 6-man. Okay, for version 7, we do a lot of extra updates to the document, and we do send it to 6-man. And 6-man people think, okay, we are fine. And then we also have received some comments from 6-man for version 8.
You're not talking about the draft. You're talking about the history of the draft, and that's not what we need right now. If there's anything new to discuss about the solution, let's do that.
Because the details will, I think they will bring some discussions. I can go to details what we have done. For example, we updated the terminology like BRv6 domain. We just redefined the use of how we use the protocol field in Bier header and the next header in IPv6 header, and some more considerations about security. And we clarify the ID needs and the co-authors. More co-authors are ended. So, and we sent this version to 6-man and synchronized to Bier as well. Okay, next version. And we do receive some comments from 6-man people to make it more clear. We have a diagram showing BRv6 per hop packet processing in IPv6 domain, how it works. And we clarification of BRv6, how it aligns with Bier architecture in Appendix A, and reference for the control plane extensions headers, which are necessary for this solution, are noted in Appendix B. And also text for the use of unicast address in section 3.2 is moved to Appendix C. That is what we have done based on the comments from 6-man. And also we put it to the main list of Bier, and we received some positive feedback. Actually, quite some feedback. I not agree that people don't interested in it. We have people interested in this topic, and they want to deploy it even in the existing network. And the working group suggestion is that we should focus on requirement document first. So we put a lot of efforts on requirement document, and we cooperate with others from other solutions. We get feedback and address comments and make sure that the requirements document reflects the working group consensus, and this document align with the requirement document.
So
and
the arguments need to be technical. Okay, we need to be technical.
Okay, sure. Some brief summary. Yes, some brief summary. This document has proposed in Bier working group for more than 2 years, and we have 8 revisions to fix all the comments that already raised by the working group. And we have more than 100 emails on Bier mailing list and 6-man mailing list to talk about whether this mechanism works. It works, and we have 5 operators support as co-authors and they think this is promising. We have 5 more drafts referred to this document, and which is not ended in this slide. We have some early implementation of BRv6, and we do some lab tests with some operators who are interested in this topic. So we really believe that BRv6 work will benefit Bier to really deploy in the network. That is the really important thing. People are interested in it. Okay, so we think.
Not right now. Next draft. All right, Jeffrey.
Okay, so these are the opinions from Sandy, from ZTE, me from Juniper, and I from Cisco, previously Cisco, and the woman from Nokia. Our thoughts about supporting Bier in non-MPLS IPv6 networks. Next slide, please.
Trying to find where to go. There it is. All right.
So first of all, is that IPv6 is nothing special to Bier. Existing procedures that we already defined for IPv4 non-MPLS networks apply to IPv6 as is. There is no need for any new changes or enhancements. Basically, the Bier header will follow the either layer 2 header or follow the tunnel header as the layer 2 or tunnel payloads. If you are using IPv4 or v6 tunnel, then you do need a new next header value defined for Bier. Now, so if IPv4, IPv6 tunneling or encapsulation is used, then it's just a transport means to Bier. And just like any other means, for example, MPLS or GRE or whatever tunnel. And this is between the BFRs that are not directly connected, and Bier header is the beginning part of the IP payload.
All right.
So between the indirectly connected BFRs, then you do not need IP encapsulation. So IP and Bier are independent of each other. That's the first fundamental concept here. Next slide, please.
All right. Let's focus on changes, Jeff.
Right. It's really not the changes in the draft. It's really about how we view how Bier can be done in IPv6 network. So this draft, Bier in 6 draft, does reflect the concepts we just talked about. So it does have one optional feature that I'm going to skip it for now. You can think that you can pretend that optional feature does not exist. So the main purpose of this draft is to specify this optional feature, or you can just ignore it, and then explain how existing Bier procedure can work for IPv6 networks. Next slide, please. Now, this alternative solution, Bier v6, now encodes the Bier header in the IP v6 destination option header. It uses IP encapsulation between BFIR and BFBRs. It uses SRv6 style handling with special MVP and EVPN procedures. And so we all know that working group requests to have a requirements draft first to justify this additional solution, because yes, we can allow multiple solutions, but if you don't have significant advantages, why bother with an additional solution? Next slide, please. So the requirements for Bier in IPv6 basically comes down to mandatory requirements that basically supports Bier architecture, and optional requirements with fragmentation IPv6 IPsec ESP header. Now, notice that there is nothing IPv6 specific in this IPv6 requirements draft.
Mm-hmm.
Next slide, please. So the Bier in 6 solution satisfies all the listed requirements, including the optional fragmentation and ESP requirements. It can be done one of the 2 ways. I'm going to skip that details for now. So in our view, Bier v6 solution, yes, the solution will work, but it's just not needed, because Bier in 6 solution, which is consistent with existing solution, satisfies all the requirements, and it does not have IPv6 overhead with Bier in with this solution. Imagine that so you don't have to burn that 40 bytes for IPv6 header. You can use that 40 bytes for bit string. There you can with that you can accommodate 320 more BFERs. That's a good thing. So basically, we don't need this additional solution, because I don't see it offers obvious benefits or advantages there. And it does introduce complexities. Next
They're
slide,
going to cut
please.
us at 5 or 10. I think we were 5 after right now. So
Okay. Next, final slide.
We're not going to vote on adoptions tonight, though.
Understand. It's just our suggested next steps. Yeah.
So this, I'd like to make a generic comment to the process as a whole. We make arguments and decisions on technical merit, not how many times things have been done, how many emails were sent, or how many discussions had taken place. The idea is we come out with a solution that sets a standard that the industry can then progress from in a way that allows us to continue doing these things. It doesn't leave us in the dead ends. And one thing we've learned is layering and independence is really important for scale and just functionality and clarity. We have Bier defined. So the question is, what does that architecture mean? And everyone's pointing to the architecture, but no one really has defined what architecture is, right? So despite all that, I think Jeffrey made a solid point here, is we need to understand the value. The only pushback I've heard is it can't be done, and that doesn't make sense to me. I see how it can be done. So if there is something specific that can't be done, that can only be accomplished by blurring the lines completely between Bier and V6, then it needs to very well be defined so that we can understand and make a decision based on it. Not on how many emails were sent, not on how many presentations were given, or not how many different authors have come to the game. These are technical decisions made by engineers who have a stake in this game. We want to make sure we don't, this is new. This is brand new, right? Multicast, multi-point transport has been the bastard stepchild of the internet for decades. And with that, we've always had to have dependencies that have crippled us every step of the way. PIM, protocol independence, was a breakthrough. We no longer depended on having RIP basically integrated with tunneling and forwarding, all in DVMRP. We tore them apart so that we can scale them independently and make them perform their best so that everyone else can perform their best as well. I don't want to forget those lessons and make those mistakes again unless we know exactly what we're trying to solve with it.
Yep, all the L3 multicast technologies in IP pretty much failed miserably. That's why Bier happened at all, right? Yep.
Okay, I think we have about 3 minutes left. Any more questions?
Yeah, we have 2 people on the mic. You want to take that? We'll be cut off in 2 minutes, right? Okay. Greg?
Zhenbin Li, go ahead.
I think there are some very significant defects in Bier 6 solution because it cannot exist independently, and it cannot satisfy what is defined in the mandatory requirements in the requirement document. Because in the case of BFR connected directly, if there is no other mechanism, it cannot do Bier forwarding. And the next, I have indicated before, the Bier 6 request in Unix header, it should be put into the transport area. And that is also recommended by the 6 working group and the AD of each area.
All right, who's next? Zhenbin?
So in fact, I think that I think this work of this over IP6 has for a long time. From my point of view, this just like from my point of view, is a little like the SRM just over UDP and the SRv6. I mean, both of these solutions can satisfy the common requirements, but on the other hand, they may have the different scenarios and the requirements to cope with independently. So I think this, maybe if we want to base the common requirement to determine the best solution is very difficult. So I think maybe we need to justify the different requirements and the scenario. Maybe the 2 solutions can coexist. That's my first point. The second point, I think, for the Bier in 6, I mentioned that well. So here, the definitely mentioned that the IPv6 is independent from the Bier layer. but I don't think so, because for example, I give this the Bier combined with the LLM. But now that the Bier LLM, if we want to do the extension for this the functionality, you know the LLM has been encapsulated in the IPv6 option. But I don't know if we want to do the Bier in 6 the LLM, we encapsulate the LLM header in the Bier layer or in the IPv6 layer. So I think this will, I mean, so this may be the issue, but maybe not in the scope of the the Bier in 6, because just like the SR or UDP does not cope with the network slicing and the LLM issues now like this way. So that's just my comments on this comparison. Okay.
Thank you. Let's keep rolling while they keep the mic up for us. So who's next here? I think Guyan, I think you were next.
Yes, so I just want to just wrap up on the feedback on the requirements draft. So, so what I heard, I think, and I think Greg, just correct me, but I think what we need to do is really circle back on really the reasons why we want to do with IPv6. Because we have a solution today that works, with MPLS and it works great, or Ethernet, but now it really is the working more on the meat on exactly why do we want to do IPv6, Bier on IPv6, and that's your main point. Is that, just correct me if I'm wrong, but is that correct?
Yeah.
Okay.
And why and how, and if there are gaps, then we address them.
Okay. All right, very good. We'll work on that. We'll get the drafts going. Thanks.
Excellent. Thank you.
you.
All right, they haven't cut us off. This was cut off at 10 after. It's 12 after. Let's keep rolling. Wait a minute. Are we supposed to give it up? No.
No.
They're supposed to give it up because of resources for the other guys. They gave us the 10 minutes early, but we have to choke it
I
out.
think they are making up for our last time.
Okay, so Sandy. So you want to cut off, Greg? Because otherwise we have Sandy on the mic, then people.
Let's take one more.
Cut out.
Take one more. We're going to
Yes,
shoot out. Sandy, go ahead.
I'd like. Yes, do you hear me?
Yes, go ahead.
Okay, I'd like to clarify that Bier in 6 solution fits all the requirements, and it works very well with Bier OAF. Yeah, that's all I want to clarify. Yes.
All right, so fortunately, we don't have to get blue sheets. It happened automatically when you logged in. All that's being done for us. Notes, Tony, please. We got the rest of this here. We had one call. We have 4 shepherds we need to dig out of this group. So please, I know this is going into a long gap between our next meeting and a lot of holidays between them, but we have to get some stuff moving along. We got a lot of stuff in our queue that we can go right now, and we'll push that, and then we got to dig us some shepherds to get the rest stuff going. And then we'll circle back definitely on this. Guyana, reach out to me. I mean, if we really work on this, I can help you out, because we need to turn this into a document that we can use.
All right, thank you, Greg. Really appreciate it. Thanks.
Thank you, guys. Anyone else? Questions, comments? All right, meet you guys in the bar afterwards.
Yeah, all right. So I have the notes taken, but I don't publish, right? I leave them like that for you to review.
Yeah, exactly. We'll take it to me, and then we'll bounce it from there.
I'll get the first
and we
round.
Take the list. Pardon me?
I'll get the first round.
Thank you very much. Hold you to it.
Okay.
All right.
Thank you, everyone.
Thanks, everybody.
That was an eventful one. See you next time. Bye.
Cheers.